Hello, my name is Bertalan Zoltán Péter. I'm with the Budapest University of Technology and Economics, and in this video, I'm going to demonstrate the data veracity assurance building block. DVA is a utility building block that ensures veracity requirements, including quality and trust standards, are met during data exchanges, and data consumers get the data they really want. Veracity requirements are established in veracity level agreements, or VLAs, which are tied to contracts. DVA provides two fundamentally different methods of assurance: attestations and proofs of veracity. In this video, I'm going to show the former, trust-based method, attestations. Trust in this context refers to the fact that the data's recipient doesn't get any verifiable proof of the satisfaction of the veracity requirements. Rather, they place trust in the data's provider or a third party who attests to its veracity, providing what is essentially a signed document stating that they have checked the veracity requirement satisfaction. In the alternative approach, cryptographically sound proofs are used, which cannot be fabricated by data providers if they do not have the data that actually satisfies the requirements. These proofs are then non-interactively verifiable by the data recipients. Both attestations and proofs are represented as W3C verifiable credentials. DVA components operate in a distributed manner and handle the issuance and verification of credentials during service chain execution automatically, without the need of manual intervention. For our demo, let's consider the following data processing chain. A data provider retrieves some data from an LMS service, such as Moodle, sends it to an infrastructure service, who anonymizes it, and then proceeds to send it to a final data consumer who uses it for AI model training. This simple processing chain can be broken down to two exchanges, one between the provider and the infrastructure service, and one between the infrastructure service and the consumer. Let's consider the first step only. For any such step, we can define roles of data senders and receivers. Veracity requirements can be defined on data flows such as the one highlighted in the figure. This figure shows an overview of a scenario where third-party attestation is used. A third party, trusted by the future data receiver, issues a verifiable credential representing an attestation of veracity to a data sender. The sender stores this credential in their SSI wallet. At a certain point in the data exchange process, the data receiver requests a verifiable presentation of this credential. In this video, we are going to look at an alternative, simplified approach where the data sender plays the role of both the issuer and the holder of the verifiable credentials representing attestations. In other words, they self-issue attestations of veracity. In this case, the data receiver has to trust the data sender to a limited extent. In the previous case, they had to trust the third party. VLAs can be defined in a centralized cloud service provided by BME. The distributed DVA service instances communicate with the centralized VLA manager during operation. Let's see how DVA provides veracity assurance in the context of a single data exchange step. Both the data sender and receiver run their local DVA service instance. Before sending any data, the data sender first communicates with its local DVA instance to create an attestation of veracity. Their DVA service runs the necessary evaluations to check the satisfaction of the requirements and issues a verifiable credential for the attestation. Then, the data sender proceeds to forward the data to the receiver. Upon receiving the data, but before continuing the data processing, the receiver turns to its local DVA instance to request a check of the data's veracity. At this point, the receiver's DVA service opens a secure channel directly with the sender's DVA, over which they request a verifiable presentation of the attestation of veracity verifiable credential. DVA can be used to check a variety of requirements. To mention a few, DVA can validate JSON schemata, XAPI profiles, or simply the fact that an XAPI statement belongs to a subset of XAPI statements determined by their verbs. We can also check the correct results of statistical aggregations or more complex statistical requirements, such as that the distribution drift over time does not exceed a certain threshold. Now let's see DVA in action. This is the front end of the VLA manager, where we can define and manage Veracity level agreements. First, we add some sample data upon which we can define our requirements. We can either paste the JSON here directly, or we may upload the file from our computer. This time, let's upload the file data.json. On the next view, we can navigate the JSON structure on the left and select its nodes. Once we select a node, we can define a JSON field level requirement about the data. Let's create one now. In this pop-up, we can choose from a list of existing VLA fragments that apply to JSON fields. Let's select the first one that uses the Great Expectations data quality engine. In this Veracity level agreement fragment, we can define that a given JSON element falls between an interval defined by a minimum and a maximum value. Let's create a requirement that prescribes that this data was created in the last year. As we click Add Fragment, it immediately appears on the right-hand side of the screen with its concrete and final syntax. Now let's try adding a generic requirement that is not bound to a specific JSON field. For example, let's add the requirement that ensures that the XAPI verb in this statement belongs to a given set. Let's use the set interacted and opened. We click Add Requirement, and this new fragment appears on the right hand side as well. Once we've added all our fragments, we can click the Create VLA button at the bottom, and we can immediately see the new VLA appear on the next view. It's the last one here. Once the VLAs are defined, we can proceed to performing data exchanges with Veracity assurance. This page is a dashboard of the DVA module where we can see existing attestation requests, verifications, and it also serves as a wallet of verifiable credentials for the participants. I have two tabs open here. The first one is for a data sender, and the second one is for the data receiver. I'm going to put them side by side. To simplify the demo from a technical perspective, we are now interacting with DVA directly without the use of a dataspace connector. Therefore, I'm going to play the role of the connector by sending direct HTTP requests to the DVA instances as if the connector were to send them. First, let's send the request that asks the DVA instance to generate a new attestation of veracity. I have two requests here. One in which the timestamp is correct according to our previously defined VLA, and one where the timestamp is incorrect as it's from quite a few years ago. Let's try sending the invalid request first. As we can see, the request succeeds, and we can immediately see it appear on the dashboard of the data provider side. However, we also see that this request failed, and it did not give us a usable verifiable credential to present to the consumer side later. Now let's create a valid request. The new request also appears on the provider's dashboard, and we can see that the quality checks have passed. We can actually see the evaluation results here at the bottom compartment, and we can also see the original data that was evaluated. So far, nothing has happened on the consumer side. Remember, we've only created an attestation of veracity, which is going to be requested for a presentation later when the consumer receives the data. Let's simulate this step by sending the necessary request to the consumer side. As we can see, nothing appeared on the attestations tab of the consumer, as this was not a new attestation request, rather a verification request for an existing attestation of veracity from a data sender. Here we can see a card appear with all related metadata and the fact that the verifiable credential corresponding to this data exchange has been verified. We can view the results of the verification, And we can also see that we can update the provider tab to see updated metadata, such as when the verifiable credential was issued and what is its ID. We can also see the verification itself on the provider side. Finally, for both parties, we can check the verifiable credentials stored in their wallets. This concludes our hands-on demo. DVA will be provided as an infrastructure service by BME. If you'd like to learn more, check out our GitHub repo or our catalog offering on the link.